Okay, so I'm gonna briefly talk through this stuff. I'm just using the stuff from the book, but this is online in the notes section. So if you want to read this in detail, I highly suggest you should. It's kind of nice, but yeah, I'm just gonna go through this, and I'll probably stop and then maybe show some examples, like working some stuff out, doing some math. So a lot of this we already know, so I'm gonna kind of go through this a little bit fast. I might just skip over some of this stuff. This is just basic stuff. Syntax, I mean, I'll talk about it. It's like the grammar for programming. You should really read over this on your own. This is going to be very, very quick. Console screen, that's what we've been printing stuff out to, or like when we take user input, we've been taking from there instead of JOption pane. Primitive variables, the int and double are the primitive variables that we need to know, primitive variable data types that we need to know for AP Computer Science. And those are the ones where, like, if you change those inside a method, they're not changed outside of a method, so that's important to know. And then, well, there we go. Hold on. I think all of this should be fine. You should skim over this, but there's nothing like fancy here. Camel case, whenever that's the first letter of a variable is lowercase, and then any other words that are in it are uppercase, so capital. So it'll be like that. That's a bad name. Those are just naming conventions. That we know about Booleans, where they can be true or false. Keywords are stuff like new or Boolean or double or public or private or void. Those are all words that you can't use for variables. They mean something in Java. Mathematical operators, it follows PEMDAS. The modulus operators, all nice and dandy. Division with integers, we've done this before. This is a really good table to look at. Just to know like what happens, like especially this as well, because 10 divided by 4 is 2, because we're doing integer division here. If one of them is a double, then it converts to a double value. For like you're not doing integer division anymore. But if both are integers and you're dividing in Java, then it'll truncate it to just 2. It won't even round up or down. This is, I guess, something nice to know. An arithmetic exception is when you divide by 0, or you attempt to divide by 0 in any way. So like these are two instances where you get an arithmetic exception. Accumulating, we should know how to do all this. These are important. These some people didn't know that, so maybe check those out. And then these are ways to increment or decrement. We know how to cast things, so casting to a double or casting to integers before you do any type of division. Just notice that when you do double, like in parentheses like this, and hits, it converts hits to a double. It doesn't convert this to a double. This would actually take this divided by that and then convert it to a double, which is not exactly what we want, because at-bats and hits are integers, so you're actually performing integer division, and sometimes you don't want to do that. Most of the time you don't want to do that, and then it's converting it to a double, so that's why this is the way it is there. Rounding a number, so I'm gonna end this video here and do a different video to actually no, we can see how to round. That's really easy right here. This is how you're gonna round things in Java. So you'd have something where you have a double, and then something where your result is an integer, and you're gonna round that. And what you do is you really just cast it into an integer and add 0.5 to it when it's a double. So here's why this works. If you have something like 53.6 and you're adding 0.5, that'll give you 54.1. But then you change it to an integer and it'll drop the 1, the 0.1. So then it rounds it up to 54. If this was 53.2, then you add 0.5. That would give you 0.7. right? 53.2, that would be 53.7. But then you change it to an integer and it drops the integer, so then the result would be 53. Hopefully that makes sense. That's how you round in Java. You take your double and you add 0.5 and then truncate, because that will either round you up. If you have a 53.5, then that rounds properly, because the plus 0.5 would round it up to 54.0, and then you drop the 0. The result is 54. Hopefully that makes enough sense. I'm going to probably go over that in class, but here it is again. And then same idea for negatives. You could just check for, do you see if you have a negative and you want to add a negative, so that's just minus 0.5, but same exact idea. So that's how you round doubles. You're going to have to do that on the homework, so make sure you pay attention to this part. Next, we have relational operators. That shouldn't be anything special. These should all be fine. I'm going to skip all this. Logical operators, we know how to use those. Truth tables, that's fine. This may be good to read over. Short circuit evaluation. It's important to understand what this means. So short circuit evaluation means if you already know the statement's true, it doesn't check the rest. So here, if 1 is less than 3, it's not going to check any of this, because 1 is already less than 3. And you have an or there, because this could be true, or all this could be true. Well, if this is true, I don't care about this. That's a good way to check for 0. That's what it's doing for stuff like this. If count is not equal to 0, and this happens. So if you put this in here, like count not equal to 0, if it is equal to 0, then it doesn't do this part. Like it doesn't even do it, because this was already something that was false. So it makes it all false right away, so it doesn't even look at that. And that way you can divide by count, even though count would be 0, but well, hopefully that makes sense. It doesn't do this part if this part already takes care of it. And so in this case, it's an and. So if count is equal to 0, then this whole thing is false, so it won't even do this. Hopefully that makes sense. We did talk about this before. To negate things, you change the and. So if I want to do not this, I change the ands to an or, and I have not A and not B. That hopefully makes sense. Or you change the ors to an and. So if you kind of this is a good way to remember it. It says to distribute, but there you go for that. Conditional statements, we know about that. I'm going to pause this and go to a section where, actually, no, I think it's good to see all of this. If else, I don't need to do this in the video. So the next important part that you're going to have to use for your homework. You should know all of this. Definitely read over this section, because it's super, super easy to understand since we know most of it already, but it's nice to have it fresh in your head. So what we are going to do, it says octal numbers as well. You're going to have a program that converts from decimal to binary to octal to hexadecimal, and it should be fairly simple. So I'm going to make a separate video for that actually right now, how to convert, just doing the math, and then you'll have to transform it into code.